Surface density of a circular disk of radius a depends on the distance as P of r is equal to a plus br. The moment of inertia about the line perpendicular to the plane of the disk is. This is a question from the chapter Rotational Dynamics, or as we call it, System of Particles and Rotational Motion. We are supposed to find out what is the moment of inertia of a line perpendicular to this disk about an axis passing through its center. Okay. Now, it is given in the question that the density is varying with respect to the distance from the center as a plus br. Okay, where a and b are constants. So a plus br is how the distance is varying. So the condition here we are going to apply here is di, the moment of inertia, corresponds to dm into r square. I'm very sure that you're all familiar with this formula. Okay, so how do you apply this? Now, first of all, we need to determine what is dm. So, dm corresponds to the mass of a small corresponding ring I have taken here. This ring is having a thickness dr and it is at a distance of r from the center. Okay, we know that mass corresponds to volume into density. Mass corresponds to volume into density. Therefore, for dm we can write this is having a circumference of 2 pi r because the radius is r and the thickness is what? dr. Therefore, we can write volume corresponds to 2 pi r into dr. 2 pi r into dr. And what about the density? It is a plus br. A plus br. Okay. Now, we have to substitute this condition over here. So, di is equal to 2 pi r a plus br dr into r square. Okay. Now let's simplify this further by opening the brackets. Let's see what you get. So r square into r, it's actually r cube. So you'll be getting 2 pi r cube into a plus 2 pi r raised to 4 into b dr. Alright. Now we are supposed to find out the moment of inertia taking into account the full disk. And it is given in the question that the radius of the disk is a, small a. So the total radius of the disk is small a. So we will have to now integrate from the center 0 to the radius a. So this will be equal to, I will be equal to integral 0 to a 2 pi r cube a plus 2 pi r raised to 4 b dr. Okay. Now applying the integral, what do you get? 2 pi r cube a. R cube is actually a variable there. It is r cube. We apply this formula. Integral x raised to n is x raised to n plus plus 1 by n plus 1. That is the condition we are going to apply here. So it is r cube here. So it will be 2 pi r raised to 4 by 4 into a, and the limits 0 to a, plus for this term it will be 2 pi r raised to 5 by 5 n plus 1 by n plus 1 into b, and the limit is again from 0 to a. Okay, so finally by applying the limits we get moment of inertia I will be equal to, some terms can be taken outside, 2 pi I'm taking it outside, upper limit minus lower limit. Lower limit is 0 in both the cases. So when you apply the lower limit, you will actually get it as 0. So just apply the upper limit and you get the answer 2 pi into a raised to 4a by 4. Fine. Plus, for the second term it will be a raised to 5b by 5. Okay. Now, a raised to 4 can be taken outside. So what do you get? From here, I is equal to 2 pi a raised to 4. Within brackets, we have A by 4 plus BA divided by 5, which is the moment of inertia of the line perpendicular to the disk and passing through its center. Clear? So in case you have any doubts, any questions you want me to answer for you, do comment below. Okay, thank you.